Okay, this is the notes for section 8.8, solving equations with radicals. So if you think about everything that we've done with radicals and with powers that are rational values, what we want to be able to do now is we want to be able to solve an equation of the form x to the m over n, where m and n are integers, and take the nth power of both sides. When we do this, we're going to find out, though, that we have to be very careful not to change the number of solutions to the equation in the process. So we'll take a look at that as we go through some stuff today. But we have to be very careful with that aspect of things. All right, so solving an equation with a single radical. Radicals, we're going to take an nth root of a number. So if we think about finding the nth root of a number, let's get a pen here. Go, the nth root of a value. Well, the opposite of taking the nth root is raising it to the nth power. So if we want to get rid of a root, all we're going to do is use a power to help us do that. All right, let's take a look at this example. It relates to the reading that you've already done from section 8.8. It says use the formula v equals the square root of tr over m from example 1. So if you think about example 1 from your reading, where t is the tension of the string in newtons, m is the mass of the ball in kilograms, r is the length of the string in meters, and refer to the art below. So as you can kind of see, here's how that's going to work. And it says what tension is needed to allow a 4 kilogram ball on a 2.5 meter string to achieve a velocity of 12 meters. So I have everything that I need there except for what I'm solving for, which is t. So I'm using this equation. I'm going to plug in what I know. I know my velocity is 12. I don't know what t is. I know that my r value is going to be 2.5. That's the length of the string, and then 4 is the mass of the ball. So we've plugged everything in, and now we're going to go through and solve for t. Well, this is a fairly straightforward one. If you think about it, to get rid of a square root, the opposite of square root is squaring. Just the opposite of the third root is raising it to the third power, etc. So I'm going to square both sides. If I do that, I have 12 squared is equal to t times 2.5 over 4. And now I'm going to go through the process of multiplying both sides. So I'm going to multiply by 4 over 2.5 on both sides. That's where I'm getting this right here. And then I can go ahead and simplify that, and we'll find that that's 230.4 newtons. So we're just solving for a variable that we don't know, and knowing the other three, and then utilizing what we know about solving equations with a single radical. All right, in order for us to do the final example that I want to look at today, we have to be familiar with the distance formula from our algebra course. So if you think about the distance formula, we know that it's the difference between x values squared plus the difference between y values squared, and then the square root of that. So we're going to use this formula here to solve this next example problem. It says find the coordinates for 2 points on a line with an equation x equals 3 that are 10 units away from the point -4, 2. So if you think about that graphically, x equals 3 is just going to be a vertical line at x equals 3, something like this. And then we have another point that is at -4, -2. So -4, -2 would be something like right in here. And we're looking for the 2 points that are on this line, okay, that are on that line, that are going to be so that where this distance is 10. That's really what we're trying to do here. Well, we're going to solve that algebraically, and what I'm going to do is I'm going to use this distance formula. I'm just going to plug in what I know. Well, I want my distance to be 10. I know that the x coordinate is going to be 3, and the other x coordinate is going to be -4. So I'm using this as kind of x2, and then this is being x1, because if it's going to be on that line, it's got to have an x value of 3. So I'm going to take the difference between those and square them. Now the only thing that I don't really know is what is that y value going to be, and so I'm going to say y minus a -2, and then I've got to square that as well. Okay. Well, in the process of doing that, what I'm going to do is I'm going to take both sides and I'm going to square it here. That will get rid of the square root. So I have this now. 100 is equal to 49 plus y plus 2 squared. Now I can subtract 49 from both sides. That's what I'm doing here, subtracting 49. So I have 51 equals y plus 2 squared. And then now, in order to do that, what I want to do is I want to take the square root of both sides. Well, in doing that, when I take the square root of both sides, really I get two separate answers, because we know that when I take the square root, it could be the positive or the negative value of that. So I have, if I do that, I have plus or minus y plus 2, because the square root and square undo each other. So basically what I'm saying here is, at this point, I'm going to have the square root of 51 is equal to plus or minus y plus 2. Okay? Now I'm going to bring the 2 over to the other side. That's where this comes into play. And then I can get both those values approximately, so about 5.14 and negative 9.14. So those would be my two y values. So in terms of ordered pairs, I would write it like that.